Assalamualaikum warahmatullahi wabarakatuh. Welcome to lecture 5, which is IIoT reference architecture. This is a new topic and it's going to be a little bit heavy. So I hope all of you can pay attention and also read a lot on this topic. In these topics, we're going to cover the M2M versus IIoT, and then the IIC Industrial Internet Reference Architecture, and then Industrial Internet Architecture Framework, and also some Industrial Internet Viewpoint. IIoT is very reliant to the machine-to-machine technology. If we know that um, the what we call the machine to machine is already in the industry for a long time. If we go back to the industry 1.0, 2.0 and 3.0, robotics, all the automations and what we call the M2M communication has been there. Okay, so only that this technology has been practiced in for decades. Okay, and then it can spark innovation, and then it result in the IoT architecture. Okay, so this is like upgrading of the M2M. Okay, so meaning that IoT only what we call might happen because the M2M is already there. Okay, so um in manufacturing process, okay, so all of this technology, IoT technology, comes with the history of the M2M, with the automation, robotic, and end-to-end communication. It is only evolution of the M2M. Traditionally, if we go for the M2M, it is more the M2M itself, okay, with the devices or the things that inside the factory or in the industry uh, is connected to the one particular apps. Okay, so let's say the car, they have their own apps that particularly just for that particular devices of a particular car. Okay, so and then for aeroplane, it is just for the aeroplane, and then for the factory is only the apps for the factory, and then the devices or the what we call the robotics or anything is have their own particular apps or services only. When the industrial internet of things come in, when it is connected with the internet inside here, okay, so it makes all of these apps interconnected together. Okay, so and it also make the things interconnected together by using the internet. This evolution creating the smart machine, smart workforce, and then if you can see that all of the devices, all of the industry can be connected at one place, and can be work. All of the information can be gathered in one center. Although we can see that M2M is like connected to the internet and then it created into IIoT, but the reality, if we go deeper, is quite different. As we can consider, there will be IIC, which is the Industrial Internet Committee, that created the reference architecture model for the industrial. In the M2M system that we know currently, they combine mixture of sensors, actuator, logic component, and also some network to allow them to interconnect and also function. The different from this industrial internet's approach, which we call as industrial system before it's connected through the internet's connection. Um, and then it becomes industrial internet system where they become connected to the internet and integrate with the enterprise system for the purpose of enhanced business process and analysis. Okay, so this IIS, which is the industrial internet system, will provide operational data via the sensors to the enterprise back-end system for advanced data processing and cloud-based advanced historical and predictive analytic. Okay, so previously it is just the M2M to the system where it analyzed, let's say, the back what we call the problem with the system itself. But currently, when we integrate the internet into the industrial internet system, they can analyze and do some predictive analytic based on that data, in the operational data, okay, in the what we call in the system of the enterprise. Okay, so the advanced cloud system also will be integrated into this system so that it will drive and optimize the decision making and operational efficiency and facilitate the collaboration between autonomous industrial control system. So this one is to realize this in order to realize this goal, IIS itself require a standard-based and open, widely applicable architecture framework so that many industry can refer to this architecture, and then they can apply the industry internet to their industry. Okay. Why do we need the reference architecture for this industrial internet? Okay, so the IIC, which is the Industrial Internet Consortium, the IIC is the what we call the people in the industry that come together to generate this architecture. Uh, they generate this architecture basically to accelerate the widespread deployment of IIS, which mean they want to create one fundamental what we call architecture so that people can refer to this architecture and then they can design their own what we call smart system in their industry. By using this framework, it can implemented when it is implemented, it can create the interoperable and exchangeable building blocks, which is what we call, meaning that this industry will be able to create their own design of smart system in their industry. Okay, so the intangible nature of the industry internet reference architecture is notable. Is designed to be flexible and cover a wide range of deployment scenario across many industries such as in energy, healthcare, and transportation, for example. Okay, so this architecture is like a general architecture, so meaning that many industry can look into this what we call the architecture that they can refer to, but it can be flexible. You can change a lot of things inside there, only that the base or the fundamental things that supposed to be there is it is going to be implemented, and with that they can play and be creative with whatever the application that they want to use. Okay, therefore, the reference architecture is a common framework that works at a high level of abstraction, meaning that it is not a strict what we call architecture where this is the thing that you must apply. This one is you have to apply. It is very abstract. It depends on your industry and your application, but they have some fundamental things that need to be followed. Okay. So this flexibility enable design to follow and adhere with the reference architecture without burdening the design with unnecessary and arbitrary restriction. With the industrial internet reference architecture, it come out with the industrial internet architecture framework. So or IIF. So this IIF is based on the ISO, IEC, IEEE standard that codes the conventions and also the common practices of the architecture design. So with this standard, it is easier for the industrial player to refer to. Okay, so by adopting the concept of this standard, those stakeholders and also viewpoint in the IF followed and construct of specification, which is why the IF is described with reference to concerns, stakeholders, and related viewpoints. So meaning that um, the component in the IIF will take what we call will consider the concern, the stakeholder, and also the viewpoint that needed in the industry. Stakeholder here is means the individual, the team, the organization, or anyone that has interest in the system. The concern, it will refer to the topic of the interest, while the viewpoint is a way of describing and addressing the concerns. So, an example of the viewpoint and how it relates to concern would be if you want to understand a system and how the machine interface with one another. The way the concern is addressed is through decomposition of the system design by drilling down to the specific interface design details and characteristic of each interconnected machine in the system. For example, you have the stakeholder here. Okay, so for example, this is the people in the business or the top of the business, and then goes to the engineer, to the technician, and then maybe the operator in the what we call in the operational area. Okay, so each of the stakeholder will have their own viewpoints and their own concerns. So based on these viewpoints, they will list down all their concerns. Okay, so when this is how in the industrial internet architecture framework will look into, so that there will be no concern from each layer of the stakeholder. The industrial internet viewpoints is classified into four class, which are business, usage, functional, and implementation. Okay, so going up through these viewpoints to from implementation to the business, the increment of validation for the stakeholder will be increasing. So meaning that this is imagine that this is people on the top of the business, and then going down, more guidance will be increased to when we go from business viewpoint to the implementation viewpoints. Okay, now let us look into these industrial internet viewpoints one by one. Okay, so for the first one is the business viewpoint. This business viewpoint will address the concern of stakeholders with regard to business-oriented matter, which mean people on the top of the business, which is your boss, the managing director, all the CEOs. Okay, so such as business vision, values, and objective. Therefore, this viewpoint are interest to the business decision maker. Like I mentioned, all the managing directors, the what we call the stakeholders in the business, the CEOs and COOs. Okay, so the next one is the usage viewpoint. This address the concern related to how the system is expected to be used and is typically represented as use case scenario with the user as actor interacting with the system to deliver a specific function. So meaning that the usage point is the viewpoint is we imagine that if we are the user of that system, what will be the concern as the user to this system. Okay, so the third one is the functional viewpoint. This one focus on the functional component in the system and how they interrelate and integrate both internally and externally with other systems. Okay, so this one with regard to the function of the component in the system, how it will function, and then what are the concerns related to the functions of the component. And the last one is the implementation viewpoints, which address the concern of functional component lifecycle and how they are implemented within the system. So the business viewpoint, of course, will address the business-oriented concern. For example, how the system deliver value to the system, to the business, and how it will align with the business strategy. Okay, so this one usually we're concerned with the financial issue. Okay, financial concern and how we are expected return or return of investment from this what we call this system. Let's say you already bring you have to use a lot of money to upgrade your system to apply the smart system, to apply the IIoT. um, the concern will be how the system that being developed where they already invest will return to them in terms of the money. Okay, so therefore the stakeholder tend to be business visionaries and decision maker who are able to identify, evaluate, and address business concern and requirement. So those who are in this business viewpoint, usually the CEO, managing directors, and all the people on the top of the company. Okay, so these stakeholders typically will have a major stake in the business and will have strong influence over decision making and a deep understanding of company strategy. So uh, those who are going to make the decision on this business viewpoint will have the major what we call power in decision making on determining the system that they want to develop inside the industry. Okay, the second viewpoint is the usage viewpoint. Okay, so the usage viewpoint take the business requirement and realize them through creation of user and system activities that deliver the required outcome and business objective. For example, in the business, they already have their own vision. What are the target that they want to achieve? By this, they take the objective, how they want to realize that objective. Okay, so this is where the usage viewpoint will take place, where it create what are the activities, they break down what are the activities needed to deliver that to achieve this business objective. Okay, so the activities described serve as input for the system requirement, which will ultimately enable the functionality required of the system. So this usage viewpoint will be the base where they will create what are the things, what are the components that they need in the system when they want to create their own system later. Okay, so what are the things that need to be achieved, to they create the activities or the requirement for that to achieve that objective. So the third one is the functional viewpoint. So the functional viewpoint will address the stakeholder concern regarding the functionality of the industry internet system. Okay, so how this, of course, previously it's usage, how you want to use that, what we call system, but now is how it will be functioning, how it will be run. Okay, so it is not an easy work to do because this will require a very large what we call application and is going to be very complex. So in order to address the concern of the IIS functionality, the IIC created the concept of the function domain model. Okay, so they create this domain so that it will be easier for us to look into the one by one part of the system in the what we call in the industry that where we want to apply this industrial internet system. Okay, furthermore, the IIC intended the concept of the functional domain to be applicable across a broad range of industries and their specific IIS requirement and specification. So, IIC, this consortium also intend this concept of functional domain can be applied in many industries. Okay, so that's why they have to specifically put that stage of the what we call the domain so that every industry can apply them. Consequently, the application of the domain model is flexible and is not intended as either a minimum or required set of functional domain. So that's why they create it to be flexible, so that all industry can utilize it. For example, the use case in the certain industry may put more emphasis on some functional domain than others. Okay, so we're going to look into this functional domain one by one. So a typical IIS can be broken into 5 functional domains. There are control domain, operation domain, information domains, application domain, and business domain. Okay, so if you can see here in this picture, there are human user on the left. Okay, and then this is the functional domain, so which mean like from the actuation and also the sensor, there will be a control domain, and then the parallel things that are going to be working side by side will be operation domain, information domain, and application board domain, and the top part it will be the business domain. Now let us look into the first one, which is the control domain. Now, the control domain basically collection of function that are performed by the industrial control system. Okay, so when we create something, they're supposed to have one control system that control all the what we call the sensors, all the what we call the end nodes, and all the overall system of that what we call functions that we create. Okay, so the core of this function comprise of fine-grained closed loop, reading data from sensors, applying rules and logic, exercising control over the physical system through actuator. Okay, so both accuracy and resolution in timing is usually very critical in this control domain. A simple example that we can see for this functional component in domain include control room in electricity utility plant, control unit in wind turbine, and then control unit in autonomous vehicles. Okay, so and many more. So this is just a simple example that you can look into. So let's see the control domain. So the control domain will comprise a set of common function, for example, that shown in the diagram below. Okay, so it start with the actuation, sensing and also actuation, and then it will be going through the communication, and then go through the entity abstraction before to the going to the modeling and also asset management. And lastly, it is the executor. Okay, so these are all the components, the common function in the control domain. Now let us look into the functions one by one. The first one is sensing. So sensing is the function that reads sensor data from the sensors. Okay, so the implementation can goes to the hardware, firmware, device driver, and software element. The second one is actuation. This is the function that write data and control signal to the to actuator to enact the actuation. So this also same like the sensing. It the implementation span the hardware, firmware, device driver, and also software element. So the next one is communication. The communication is where it connect the sensors, actuator, controller, gateway, and other edge system. Okay, so the communication mechanism take different forms such as the bus, network architecture, and also the some statistical configure and other dynamically. So the next one is entity abstraction. It provide the abstraction of score of sensor and actuator, peer controller and system in the next higher tier, and express relationship between them. Okay, so next one is modeling. So modeling deal with the understanding the states, condition, and behavior of the system under control and those of peer system by interpreting and correlating data gathered from sensors and the peer system. Okay, so in this modeling, all the data that gathered by the sensors will be analyzed, and then they will see what will be the problem, or there will be what will be the next step to be done. Okay, so via this modeling function. Okay, and then we do have asset management, the next one, which enable operation management of the control system, including system on board configuration, policy system, software, firmware updates, and other lifecycle management operation. This is the same like our laptop, for example. If we have a laptop, from time to time there will be updates that you have to download, and then you have to what we call updates your computer, the driver or something like that. So this is the same for the system in the control domain. um, Only that this of course will be bigger in term of the system. Okay, so the last one is the executor. This executor will execute control logic to the understanding of the state, condition, and behavior of the system under control and its environment in accordance with the control objective. Okay, so the control objectives may be programmed or otherwise set by static configuration, be dynamic under authority of local autonomy, or be advised dynamically by state system at higher tier. Lastly, the executor. There are two types of executor. One is straightforward and another one is sophisticated. Okay, so for straightforward is relatively a very simple control mechanism through feedback via algorithm to control, for example, the boiler. Okay, so but for the sophisticated one, they use the technique that incorporate aspect of cognitive and also machine learning technologies, which provide high level of autonomy, and this will allow the machine to make its own best or worst decision. Thank you for listening. So we're going to continue with part 2 later.